We're going to talk now about another operation that we can perform on matrices. So this operation is called the transpose. So the transpose has some uses that we'll see down the line in the future. It's a good way for example, for computing inverses. But it also has a bunch of other uses that in this class we won't quite get to, but it is a very important operation. So what is the transpose of a matrix? Well, let's start out with an example just to kind of see it happen. So if A is the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Then the transpose of this matrix is 1, 4, 7, 2, 5, 8, 3, 6, 9. Right? So can you kind of see what happened here? All these rows, row 1, row 2, row 3, are now column 1, column 2, column 3. Right? So the rows are read left to right as usual, columns are read top to bottom. Right? So what we're doing is we're turning rows into columns, and likewise we're turning columns into rows. Another way to think about what the transpose is imagine, we draw the main diagonal of the matrix, right? So I'm going to draw a line through it here. And what we do is we sort of flip everything over this diagonal, right? So this 4 goes to this 2 goes to that 4. This 3, the corresponding thing on the opposite side of the diagonal, is 7, and likewise 7 for 3. And then the 6 and the 8 get switched. And everything that's actually on the diagonal, you'll see, stays exactly the same. Right? Let's do one more example of the transpose. But let's do it for a matrix that's not a square. So 1, 2, 3, 4, 5, 6, 7, 8. Right, so here's a 2 by 4 matrix. Then the transpose, remember, we're switching rows for columns and columns for rows. Or, again, you can imagine kind of flipping along this diagonal here. Right? That diagonal. Right? So either way you think about it, this has got to become a 4 by 2 matrix now. It's going to be 1, 5, 2, 6, 3, 7, 4, 8. Right? So hopefully that kind of makes sense. Right? And again, here's the diagonal that didn't change. Right? So let's give you the actual definition. Okay? So the transpose of the matrix A equals Aij is the matrix, right? A transpose, and what it is it's just Aj, right? So you take all the entries from this matrix and you flip them around, right? So maybe a better way to write this could be, maybe let's say this is Cij, where Cij equals Aji. Maybe that's a better way to kind of look at it here, right? So if we went to, say, row 2, column 4 in the original matrix, that would correspond to row 4, column 2 in the new transpose. Right, so hopefully that makes sense, and it's not too bad. And to finish up this video, let's talk about some properties. Right, so properties of transposes. Alright, so what are some properties here? So what we're going to say is, as usual, A and B are matrices. C is a scalar. C a scalar. All right. Then the properties below are going to be true for transposes, right? So 1. If we take the transpose of the transpose, what do you think is going to happen? So for each of these properties, I'm going to write the one on the left side, say think about it, see if you can figure out what it should be. Right? Pause the video if you need to. Right? So the transpose of a transpose, here we're going to flip it and then flip it again. That should just bring us back to the original thing. The 2. What if we add 2 matrices and then transpose? Well, that's the sum of the transposes. Okay. 3. CA transpose equals C times A transpose. All right, so this looks a little weird. Let's put some parentheses here. Right? So we can factor a scalar out of a transpose. Right? And lastly, this is the most interesting one. What do you think if we multiply 2 matrices together and then transpose? What do you think? What do you think? This one here has the most interesting of these 4 properties, I think, which is that it actually switches the order of the transposes, or it switches the order of the matrices. And in a way, this kind of makes sense here because we're flipping the matrix, we're swapping columns and rows. And if you think about how matrix multiplication works, it's rows of the first one times columns of the second. So if you flip both matrices on their ends, then think about how that should probably work out there. All right, so we'll leave it here for this one. Hopefully that makes sense, and I'll see you for some inverses next.